We're now going to be going over Chapter 7 in the Foundations book, Electricity and Electrical Safety. Our learning objectives are explain electricity and electrical safety, outline electrical theory, practice electrical equipment safety, identify electrotherapy modalities, and discuss light therapy. Understanding why we're even going over electricity and electrical safety for aesthetics, you might think like, what's the point, right? But think about all of the things that we use with electricity that we need for doing our services. So even just waxing and facials and back treatments that we've covered so far, think about all of the things that we have to do those services. There might be some things that are possible without electricity that you could do. For example, like I could probably give a full body massage without electricity because I don't really need to see anything and I don't really need a light most of the time. But during the summer, it gets very, very hot and just inside in general. Like without electricity, we don't have air conditioning, or in the winter, we don't have heating, and that can get very uncomfortable very quickly if the power went out, for instance. So we're using a lot more electricity than you may just think about in general, and that's why we're kind of covering this. I also want to mention, I know that this chapter in particular is a very vocabulary heavy, so a lot of it is just going to be me reading off vocabulary words, at least for this chapter. Electricity itself is the movement of electrons from one atom to another along a conductor. So electricity is a form of energy that when in motion, it exhibits either magnetic, chemical, or thermal effects. Electric current is the flow of electricity along a conductor. So materials are either classified as conductors or non-conductors, depending on the ease of how electric current can travel through them. A conductor is any material that can conduct electricity. So metals are good conductors because the electricity passes through the material very easily. Copper being especially good and more commonly used in electric wiring and electrical motors. Pure distilled water is actually a very poor conductor because it has neither a positive or electrical charge. But ordinary tap water, river water, lake water is actually a good conductor because there is ions in it and it's either positive or negative, which is why you shouldn't swim during a storm. A non-conductor or insulator is a material that does not transmit electricity, so things like rubber, silk, wood, glass, and cement. Those are good conductors because electricity current cannot travel through them. So when we think about a conductor and an insulator, metal wires, the conductors are going to be typically covered in an insulator, so thinking of wiring is covered in rubber, so the conductor is inside of the insulator, or the insulator surrounds the conductor to prevent shock and all of the bad things that come with electrocution and, all that stuff. Yay. A complete circuit is the path that negative and positive electric currents take from the generating source through the conductors and back to the generating source. So circuits are almost like a circle. So think of circuits, and circles are going from one thing to another back to the other thing in a circle pattern. The types of electric current, we have direct current or DC, which is a constant even flowing current that travels only in one direction. So it's a direct current going in one direction, and it's produced by chemical means. So flashlights, cell phones, cordless tools that use direct current produced by batteries. An inverter is an apparatus that changes direct current to alternating current, which usually has a plug and a cord. So a phone charger in a car would be an inverter. Alternating current, or AC, is a rapid interrupted current. So it flows in one direction and then it goes into the opposite direction. and it's produced by mechanical means and changes directions 60 times per second. And quarter devices that plug into the wall outlet are using alternating current as well. And a rectifier is an apparatus that changes alternating current to direct current. So this would be a regular phone charger that recharges batteries. For electrical measurements, we have volt or V. Voltage is going to measure the pressure or force that pushes an electric current forward through a conductor. The higher the voltage is going to indicate more power. The way I remember volt, at least, volt meaning pressure or force, I think of Pokemon, I think of Pikachu like casting Thunderbolt, because bolt reminds me of volt, it rhymes together. So Thunderbolt is going to have a high pressure or force of electric current, right? Ampere or A or amp measures the strength of electric current. The way I remember this one is like if you're strength training at the gym, for instance, you have to like amp yourself up to push harder or do a little bit more weight, right? So you have to be strong and you got to amp yourself up. So amp is strength. Milliampere or MA is 1/1000th of an ampere. So most of our devices are measured in milliamperes just because a full ampere's current would be way too strong and way too dangerous. So whenever you see milli in front of something, just know that it's 1/1000th of whatever you're measuring. Ohm or O measures the resistance of electric current. So current will not throw through a conductor unless the force or the volts is stronger than the resistance or the ohms. The way I remember that ohm is resistant is because it sounds kind of like ohm and if you're like thinking or you're umming, you're kind of resistant to something, right? So if you're like, I don't know what that means, it's you kind of have a resistance, right? So ohm is resistance. Watt or W measures how much electrical energy is being used in 1 second. So for example, a 40-watt bulb is going to use 40 watts of energy per second. And I honestly don't have a good way to remember this one. Just have to remember that this is the other one, if you can remember the other 4. Kilowatts or kW is 1000 watts. So anytime you see kilo, that is 1000 times whatever measurement it's connected with. Electricity measured in your house is going to be measured in kilowatts per hour or kWh, and a 1000 watt microwave uses 1 full kilowatt of energy per second. Our first question is to define the 2 types of electric current. Some electrical safety devices that we need to know are fuse. So fuses prevent excessive current from passing through a circuit. It's designed to blow out or melt when the wire becomes too hot from overloading the circuit with too much current caused by either faulty equipment or too many appliances connected to an electric source. Fuses do need to be replaced if a fuse breaks and are typically only used in older buildings that haven't been renovated. So we don't normally have these around too much anymore. A circuit breaker is a switch that automatically interrupts or shuts off when there is a first indication of an overload in the electric circuit. These are more common now since they've replaced fuses and they don't require replacement and can simply just be reset by switching the breaker right back on. If a circuit breaker does shut off, you need to disconnect any of the appliances that were connected to that particular breaker and check all the connections and installations before resetting it. Grounding completes an electric circuit and carries the current safely away. All electrical appliances must have at least 2 rectangular electric connections or prongs on the plug, so the thing that you actually plug into the wall. The 2 prongs supply the electric current to the circuit. One prong is slightly bigger than the other, which guarantees that it can only be inserted one way. For extra protection, some appliances, especially the bigger ones, are going to have a third circular electric connection that is called a grounding pin. So it's called a 3-prong plug, and it's designed to guarantee a safe path for electricity, and it's to protect the user from an electrical shock even if the wire comes loose. And these offer the most protection for you and your clients. So a lot of the times you'll see those for the bigger devices that we use. A ground fault interrupter, or a GFI, is designed to protect from electrical shock by interrupting a household circuit when there is a leak in the circuit. And these are required by the electrical code for receptacles in bathrooms, kitchens, and some outside receptacles, so anywhere where water is most likely to be. GFIs are designed to detect currents of a few milliamperes and trip a breaker at the receptacle or at the breaker panel to avoid a shock hazard. On the GFI, there would be a small green light typically, and that would turn red when it trips. And when the appliance is removed from the socket, it can be reset with the reset button on the panel. Underwriters Laboratories, or UL, certifies the safety of electrical appliances, and any electrical device should be UL approved since it certifies that they are safe when used and according to the manufacturer's directions, as if it is UL certified. Some guidelines for the safe use of electrical equipment include all electrical appliances that you should use should be UL certified. You should read all the instructions carefully before using any piece of electrical equipment. Always register electrical appliances with the manufacturer so that you will be notified of any safety recalls immediately. Disconnect all appliances when not in use. So pull on the plug, not the cord, to disconnect it. Disconnect all electrical appliances prior to cleaning them. Never poke hairpins or wires through any part of an appliance, including the lint screens. Inspect all electrical equipment regularly. Keep all wires, plugs, and electrical equipment in good repair. So do not use cords that have exposed wiring in any part of the cord or where it attaches to the appliance. Use only one plug in each outlet because overloading can cause a circuit breaker to pop. And if more than one plug is needed in an area, use a power strip with a surge protector. Avoid contact, for both you and your client, with water and metal surfaces when using electricity, and do not handle electrical equipment with wet hands or while standing on a wet floor. Keep electrical cords off the floor and away from everyone's feet because getting tangled in a cord could cause you or your client to trip. Do not leave your client unattended while the client is connected to an electrical device. Do not attempt to clean around the electrical outlets while equipment is plugged in. Do not touch two metal objects at the same time if either is connected to an electrical current. Do not step on or place objects on electrical cords. Do not allow electrical cords to become twisted because this can cause a short circuit. And do not alter a 3-prong plug to fit into a 2-prong outlet. That seems silly. Do not attempt to repair electrical appliances. If you see sparks when plugging or unplugging an appliance, do not use the appliance or outlet until it has been approved by a certified electrician as safe to use. Verify regularly that fire extinguishers are appropriate for electrical fires, are not expired, and that you are comfortable with using one. Remove lint from clothes dryers before each load to reduce the chance of a fire as well. Low voltage shocks are rarely critical, but they can be quite painful and dangerous to some individuals. If you receive a light shock sensation while using, turning on or off, or plugging in or unplugging an electrical appliance, you should stop using the appliance immediately and turn it off completely. Unplug it from the wall or turn off the circuit breaker to the outlet. Replace the appliance or have it repaired by an authorized repair representative. If similar issues occur with other appliances in the same outlet, discontinue the use of that outlet until it's approved by a certified electrician. If you drop an electrical appliance in the water, so you got a bath bomb or something, electrical bath bomb, if the outlet is a GFI protected, it should kill the circuit immediately, and you may unplug the appliance from the wall after releasing the appliance. Do not have one hand in the water and one on the outlet. If the outlet is still live, your body could conduct with the electricity. If the outlet is not GFI protected, go to the breaker box and flip off the current. If you are unsure which circuit controls that outlet, it's better to just shut off all of the power to everything while you fix the situation. And once the power is off, unplug the item and then restore the power. And you should never use an appliance that has been dropped into water. You should seek medical care after an electrical shock if you are pregnant, if you have burns on the skin, or particularly those that are open and do not heal well over time, or if you're not current on your tetanus immunization, which are given every 5 years for adults. And question number 2 is, what are at least 5 steps to take for electrical safety? Electrotherapy is the use of electric currents to treat the skin. Modalities are currents used in electrical facial and scalp treatments, and each modality produces a different effect on the skin. So, for instance, some modalities would be galvanic current, microcurrent, and Tesla high-frequency current. An electrode, or also known as a probe, is an applicator for directing electrical current from an electrotherapy device to the client's skin. It's usually made of carbon, glass, or metal, and each modality requires 2 electrodes, one negative and one positive, to conduct the flow of electricity through the body, with the exception of Tesla high-frequency current, which is only using one electrode. Polarity refers to the poles of an electric current, either positive or negative. Electrodes on an electrotherapy device have one negative charged pole and one positively charged pole. So the polarity is just either negative or positive. Anodes are the positive electrodes. Usually they're going to be red or marked with a P or a plus sign, and so an anode being a positive polarity. Cathodes are the negative electrodes. Usually they're black or marked with an N or negative sign, and those negatively charged electrons from the cathodes are what flow to the positively charged anodes and causes different reactions in the skin or with different products that are on the skin. Galvanic current, which we will try more of next semester, is a constant and direct current. It has a positive and negative pole that produces a chemical change when it passes through the tissues and the fluids of the body. There's 2 different chemical reactions that are possible with galvanic current, depending on the polarity that's being used on the skin, so either the positive pole or the negative pole. The active electrode is the electrode that is being used on the treated area. So the electrode that is active is being used on the face, and the inactive electrode is the opposite pole from the active electrode. So that would be the one that normally the client would be holding. Iontophoresis is the process of infusing water-soluble products into the skin with the use of electric current, like using the positive or negative pole on the galvanic machine. Cataphoresis is infusing an acidic or positive product into the deeper tissues of the skin using galvanic current from the positive pole toward the negative pole. Anaphoresis is infusing an alkaline or negative product into the tissues from the negative pole toward the positive pole. Desincrustation is a form of anaphoresis, and it's a process that's used to soften or emulsify oil deposits or blackheads in the hair follicles. Desincrustation is frequently used to treat acne, milia, or comedones. So this is typically used right before you do extractions on someone, if you're going to do extractions. So with galvanic current, just to kind of recap, if you are using a positive pole or anode on the skin, that's the active anode, you are doing cataphoresis. So that's going to be producing an acidic reaction. It's going to close the pores, it soothes the nerves, it decreases blood supply, it contracts blood vessels, and it hardens and firms tissues. If the active pole that you're using is a negative pole or a cathode, you're doing anaphoresis. This is producing an alkaline reaction. It opens the pores, it stimulates and irritates the nerves, it increases the blood supply, it expands the blood vessels, and it softens tissues. Microcurrent is an extremely low level of electricity that mirrors the body's natural electrical impulses. Microcurrent can be used for ionophoresis, firming, toning, and soothing the skin. It can also help heal inflamed tissue like acne. Newer microcurrent devices have negative and positive polarity in one probe, so not having two probes, which allows the client to relax rather than having to hold onto a probe during the service or treatment. Microcurrent does not travel through the entire body like galvanic does. It only serves the specific area being treated. So microcurrent can be effective in the following ways. It can improve blood and lymph circulation. It produces acidic and alkaline reactions, increases muscle tone, restores elasticity, reduces redness and inflammation, minimizes healing time for acne lesions, improves the natural protective barrier of the skin. When microcurrent is also being used during anti-aging skin treatments, it may give your client's skin a softer, firmer, and more hydrated appearance. Tesla high frequency current, or we normally just call it high frequency. It can also be called a violet ray. It's a thermal or heat producing current with a high rate of oscillation of vibration that's commonly used for scalp and facial treatments. The Tesla current does not produce muscle contractions, and the effects can be either stimulating or soothing depending on the methods of applications. Electrodes are made from either glass or metal, and only one electrode is used on the area to perform a service. When we hear contraindications, that's just referring to there's a condition that requires avoiding certain treatments or procedures to prevent an undesirable side effect. So contraindications are just reasons to not do something or use something. So for example, contraindications for Tesla high frequency would be someone that is pregnant or has epilepsy or any other seizure disorder, asthma, high blood pressure, a sinus blockage, a pacemaker, or metal implements. Also, clients should avoid contact with metal during any electrical therapy service. So taking off jewelry or metal bobby pins or nose rings, piercings, anything like that would be metal and would need to be avoided. Our question 3 is, what are 3 electrical modalities used in beauty and wellness services? The electromagnetic spectrum, or known as the electromagnetic spectrum of radiation, is the name given to all forms of energy or radiation that exist. The forms of energy in electromagnetic spectrum are radio waves, which are used by radios and televisions, microwaves, which are used in our microwave ovens, light waves like infrared light, visible light, and ultraviolet light, which are used in light therapy services, X-rays, which are used by physicians and dentists, and gamma rays, which are used for nuclear power plants. Energy moves through space in waves. So these waves are similar to the waves caused when a stone is dropped on the surface of water. So it kind of makes that ripple effect or the wave of the water. And each type of energy has its own wavelength. So the wavelength is the distance between a successive peak of electromagnetic waves. A waveform is the measurement of the distance between two wavelengths. So some wavelengths are longer and some are shorter. Longer wavelengths have a low frequency, meaning that the number of waves is less frequent, or there's fewer waves within a waveform pattern. Short wavelengths have a higher frequency because the number of waves is more frequent, so there's more waves happening within a set waveform pattern. So long wavelengths have a lower frequency, they're going to have a deeper penetration, and they also have less energy, while short wavelengths have a higher frequency, they penetrate less, and they have more energy. Visible light is the part of the electromagnetic spectrum that can be seen. It only makes up 35% of the natural sunlight. Of our visible light, violet has the shortest wavelength and red has the longest wavelength. The wavelength of ultraviolet light is right below where we can see our violet light, and it has the shortest and it's the least penetrating light of the spectrum, while infrared light is right above where we can see red, and it has the longest and most penetrating light, and it produces heat. Invisible light is the light that is at either end of the visible light spectrum, so above red and below violet, and it's the light that is invisible to the naked eye. And this actually makes up 65% of natural sunlight. So the infrared light and the ultraviolet light, those are invisible, we can't see them, but it makes up most of the natural sunlight. Ultraviolet light, or UV, is known as cold light or actinic light. It's invisible light that has a short wavelength, so more energy. It's less penetrating than visible light, and it causes chemical reactions to happen more quickly than visible light. It produces less heat than visible light, and it can kill some germs. UV light also prompts the skin to produce vitamin D, which is a fat-soluble vitamin that is good for bone growth and health. Overexposure, though, to UV light can cause some premature aging of the skin and skin cancer. It's estimated that 1 in 5 Americans will develop skin cancer, and that 90% of those cancers will be the result of exposure from UV radiation, from natural sunlight, sun lamps, and tanning beds. UVA has the longest wavelength of the UV spectrum, and it penetrates directly into the dermis of the skin, damaging the collagen and elastin, and is also often used in tanning beds. So when we think of UVA, we think of aging. So UVA is the aging light. And UVB is the burning light. So UVB is burning because it's most associated with sunburns. And excessive use of both UVA and UVB can both cause skin cancer, which is why we should use our SPF. UVC is blocked by the ozone layer, but if the Earth loses its protective layer of the ozone, life would literally no longer exist. But UVC is effective at killing bacteria, viruses, mold, and other pathogens too, so it's not all bad. Infrared light, which is my favorite, has longer wavelengths and penetrates more deeply. It has less energy and produces more heat than visible light. Infrared light also makes up 60% of all natural sunlight. It's used in spas and in saunas for relaxation and for warming up muscles. It's also actually been used to diminish signs of aging like wrinkles, and also to heal wounds and increase circulation. Catalysts are substances that speed up chemical reactions. Some catalysts use heat as an energy source, while others use light. And whatever energy source the catalyst uses, it absorbs energy like a battery, and at the appropriate time they pass the energy to the initiator and the reaction begins. Like other chemicals, a catalyst does not get consumed in a chemical reaction. And an example of a catalyst would be UV light in an application of gel nails. The UV light is the catalyst for the hardening of the gel nail. Light therapy is known as phototherapy. It's the application of light rays to the skin for treatment of wrinkles, capillaries, pigmentation, or for hair removal. Lasers and light therapy devices have been used for decades, and yet some of their original techniques are still valid today. Lasers are designed to focus all light power into a specific depth and in one direction within the skin, using the same color of light. And in contrast, other light therapies have been used in multiple depths, colors, and wavelengths, and the light may be scattered. The most important point to remember about light therapy is that the equipment that you use is selected based on the skin type and condition that you're treating. And our question 4 is to describe the positive and negative effects of ultraviolet light. So the learning objectives that we've covered were to explain electricity and electrical safety, outline electrical theory, practice electrical equipment safety, identify electrotherapy modalities, and discuss light therapy. And that will conclude our Chapter 7 in the Foundations book for electricity and electrical safety.